Hi everyone, welcome to the next video in the Bell the Cat series of videos. My name is Tony Xavier. I'm the Chief Learning Officer of IMS. The Bell the Cat series of videos are part of a companion volume to my book called Bell the Cat, which is available on Amazon. This is the third video in quantitative ability that we're looking at. So in the first video, we saw what are the basic steps to solve any quant question, what is a standard operating procedure. The next video we saw how do you learn stuff, how do you, if you're not really comfortable with math, how do you approach learning math. And this is the last part. You know the process to solve, you've learned the concepts. Now that all of that is clear, how do you actually try to look at elegant solutions, thinking without ink, without putting pen to paper. Why think without ink? So that you don't put pen to paper and can you solve questions verbally. Now, we know that on with respect to the elegant solution, it is not that every question can be solved this way. Can every question be solved this way? Not necessarily. But having that mindset is important because in a cricket match, do you think every ball in a T20 match especially, every ball can be played with a scoop or a ramp? Not possible, right? Only some particular balls can be played that way, right? In an entire innings, maybe you'll play 3-4 shots. Rishabh Pant is a very, very different player because every ball he tries to hit behind the wicket. But otherwise, it's only a few shots. So does that mean that people decide, okay, anyway, it's a few shots, why should I do it? No, because finally the victory, the difference between victory and defeat can be just a few boundaries here and there. Similarly, a few questions solved very fast and having that mindset might save you from that extra, give you like 4 minutes extra or 5 minutes extra in which you can solve maybe 2 questions in a traditional format, right? So that's why we're looking at the elegant solution. And I feel the things that you need to arrive at elegant solutions always help you in terms of solving the questions properly, even if you're doing it the traditional method. Yeah, let's take a look. In the first video, we discussed writing is not thinking. So that much we've established that writing is not thinking. So if writing is not thinking, then the best solutions should involve no writing or minimal writing. You're just keeping your hands free and you're solving, right? Obviously, if writing is not thinking, if you're completely thinking and solving, that's the best method. So the question is, how do we learn to think better, think clearer, and think efficiently, right? So if something is better, clear, and efficient, all of that points to one thing: these solutions are elegant. Very classy, beautiful solutions to look at, rather than a painful, long solution, right? So, in other words, what are we going to learn in this video? How do we learn to think elegantly? So, I was not, born with these skills to do all of this. Over a period of time, different people, when I saw the way they solved, that is how I learned to become better at things. So it's not as if everybody is born with this. So this is one of the things that I'd always like to repeat to students, that we think every single thing is natural. No, 10 things will come naturally to you. A few things, you see somebody else doing it, you'll be like, oh, I never thought this was possible, and let me try it, and then you start getting better. Right? So this is a big misconception that everything is natural. This is in the case of sportsmen, it applies, perfectly. You might be very, very good at all the shots, but there'll be one shot that you'll have to learn to get better at that way. Now, how does this process? Usually what people do is, there is a solution and say, I have a shortcut. So usually what people do is they teach you the regular solution and then they'll say, I have a shortcut. Now, if I tell you I have a shortcut, you don't know why and how is there a process to do that shortcut. My whole goal of teaching is to show what do people who do, what is the process behind it, because behind everything there is a process, right? You might not see it, they might not be able to articulate it. So if it is only shortcuts video, I can do many shortcuts videos, but there is no point unless you are able to do it. So for elegant solution, what I'll be looking at, I'll be giving you a few principles, because just like there is not just one shot behind the wicket, right? There is the ramp, there is a scoop, there is a reverse scoop, there is a reverse sweep. There are different methods. Similarly, even for shortcuts, there are different kinds of shortcuts. But what is the process behind it is what I'd want to explain in this. So the first one, look out for magic numbers. What do I mean by this? Most important, don't rush to play the ball. Let the ball come to you. right? That's a very, very important part. Let the ball come to you. Sometimes it's better to use the pace of the ball. What happens is, when you give the information, suppose I give you some information, straight away you can say that I'll put it into a formula. But if you spend that 10 seconds more, it's not a lot of time, it's 10 seconds more. So what is the information that is being given? Is there something peculiar? And is there something magical about the information? I want to give you this before we solve a question, so that if you can come up with the trick yourself, or you can decode it yourself, I'll be so much more so much more happier, because so that you are doing it. You don't need to wait for me to tell you that, right? So when you get the information, don't try to immediately fit it into a formula. That part you can always do. You can always fit it into a formula, but just see if there is anything unique about the information given. When you actually look at the information, what are the specific thing, you will see that the elegance will reveal itself, right? For that, I don't know if you remember the movie, The Beautiful Mind. If you haven't seen the movie, you should watch that movie. It's about a famous, a mathematician called, John Nash. So in that, he's always seeing the numbers. So the person whom I learned this from a lot, a colleague of mine who's like, the god of cat. He has, I don't know, I think more than 1400 percentiles at least overall, on the cat. So these things I learned from him. This is the specific thing I learned from him. Different people have taught me over the years, but this is the specific thing I observed from him, that he does not look at information as, say, to go into a factory or this thing. He just puts that information on a whiteboard, and then he lets the information see patterns in the information. Now, the moment you see this question, formulas are screaming at you. Okay, use me, because there is a formula, right? What is the formula? Straight away, what is the standard method? You know that a plus 11d divided by a plus 8d is equal to 24 by 17, right? Because ratio of 12th term, you know that nth term of an AP is a plus n minus 1 into d. So you straight away do this. The moment you do this, you know that I'll get a in terms of d. I need to know 6th term to 3rd term. I'll do a plus 5d by a plus 2d, and I will easily get that because I'll express a in terms of d. Whenever I've shown this problem to anyone, straight away this has been the approach. Everybody jumps to do this, right? But I said, look at the numbers, and do they reveal something? Do they reveal something elegant? So if you look at the numbers, what do you know? 12th term, 9th term, they've given you the ratio. They're asking you for the 6th term and the 3rd term. Notice something? 12, 9, 6, 3. All the gaps are equal. 12 minus 9 is 3, 9 minus 6 is 3, 6 minus 3 is 3. So in arithmetic, it's an arithmetic progression, and all terms are equally spaced. What is an arithmetic progression? Between any two terms, the gap will be the same, right? So if between two consecutive terms, the gap is x, here the number of terms between 9th term and 12th and 12th term and 9th term are 3 terms. So the gap will be 3x. So the gap is consistently 3x, right? So if we know that it is 12, 9, 6 and 3 and the gaps are equal, then if the ratio of 12th to 9th is 24x and 17x, what is the gap? 24x and 17x? 7x. The other terms also should have the same gaps. 12, 9, 6, 3, all the gaps are equal. So 24, 17, 17 minus 7 is 10, 10 minus 7 is 3, right? Because any two consecutive terms, the gap is the same. So if the gap is x, here the gap is of 3 terms, so 3x, 3x, 3x. So it's all are evenly spaced. That's the beauty of an AP, and that's how you get this answer. Yeah. So anytime you see that problem, you see this thing happening. Now, one thing is very important. Sir, every question like this can I solve? Not necessarily. Suppose these numbers are different. As I said, elegant solutions, sometimes what test takers do, setters do is, I'll leave a couple of these questions with these magic numbers. So those who solve and get that 100 percentile, those who are able to solve all the questions, They're able to do that because some of these questions, they're able to hit these reverse sweeps and they find the elegant solution. So they have time later. Even test setters do that in the sense of very deliberately knowing, how do I separate the 100 percentiler from the rest, or how do I differentiate between students who are very good and students who are good, or test takers who are very good and test takers who are good. I leave these small things as a hint. Those who can pick these up will do more questions and hence get a higher score. So the same thing is not possible if instead of 6th term and 3rd term, it was 5th term and 2nd term. Not possible. Then the gap would be what? 3 terms here. Between 9 and 5, it will be 4. And between 5 and 2, again, it will be 3. So the gaps are not even. So the key is to look at the question, look at the numbers, and see if there is anything unique. So the first kind of thing is to look at, this is one way of looking at, where you pause and just for that fraction of a second, examine the information to see, is there some magic possible, right? So the answer on this one, 10:3. Second principle, know the standard alternatives. If you see, if there's something is standard and what is an alternative, this means that you know that you think batsmen are on the spot deciding after the ball is pitching that which shot they're going to hit a scoop. No. They have a few things in mind. What do they know? They know that if a ball is roughly anything is say coming towards the middle and leg, and they know that some lines and some length, I will always play a shot. This shot is always on, right? So for example, some people might decide that for the spinner, any ball that is pitched at a particular spot, somewhere within my reach, I will sweep. Anything which is beyond that, I won't sweep, right? I remember even in my college, there was this guy who was like a fantastic hitter. Huge guy, tall guy, very strong. His cricket technique was very simple. I think, back in the day, studying only was most important. This whole, T20 sports and clubs were not really encouraged, that much. So he used to stand right at the crease. He's a tall guy. So what he would do was, he would draw a circle. He would extend the bat like that, and he would draw a circle around him, semicircle. He knows that in that semicircle, if the ball, he judges that the ball is going to pitch, that means he has the reach there, right? He is going to go for it. If the ball is falling outside that, he's going to go into the back foot, but anything in his arc, he knows that he will judge that, he'll draw that, and if he's judging the ball to fall there, he'll just go to and hit sixes. That's about it. Clean six hitting with that semicircle around him, right? Similarly, some areas like time, speed, distance and time work will always, you can always do let the distance be d, way of solving, but there is always a chance to solve elegantly using ratios. This elegant solving using ratios is something that again I learned from my first math teacher. I was always good at arithmetic, absolutely, my favorite area. But when I was preparing for CAT, I saw that every time speed distance problem, I am always trying to write S into T is equal to D, right? That is that, and they lived happily ever after story. But then I saw that the teacher was solving it differently. He was always solving using ratios. What do I mean with ratios? Speed is doubled, time becomes half. Speed is tripled, time becomes half. Time is 1/3. That means speed should have become thrice. He was always using ratios. And even now I remember when he used to teach, he would say up, down, speed is double, time is half, And the moment I saw it, I realized, okay, I'm getting the answer, but I'm taking 3 minutes or maybe even 2.5 minutes. He's doing in 30 seconds. I should go and do that. But this is a very, very important lesson to learn, because think about it. You might think, no, but I'm getting the answer. No, sir. Average time is 2 minutes. I'm solving it in 2 minutes. So why should I change from what I'm comfortable? Think about it this way. Tomorrow you are the product manager of a particular company. Your product is doing the job. Absolutely fine. It is taking the photos. But somebody else has the same product at a lower price. Or somebody else at the same price, they're giving better features. What will happen? You will be out of business, right? So this thing of optimizing, this thing of finding the best solution has to be in your head. Whether you know to solve something or not does not matter. Yeah. So let's look at this question. I'm giving you a clue beforehand. that this can be solved using ratios. There is a standard method, but as I said, I'll be most happy if you get the method before I tell you. Right. Now, what is the template to solve? Template is to solve it linearly. He's saying, he's taking 3 steps forward and 1 step back. What is this person doing? In 3 steps forward, 1 step back, one in each step is 1 second. So 1, 2, 3, back. 1, 2, 3, back. So every 3 seconds, first 3 seconds, I'm taking 3 steps. In the 4th second, I'm taking 1 step back. So every set of 4 steps, I'm taking 2 steps forward. He walks up a stationary escalator and reaches the top of the escalator in 118 minutes, right? So we're saying that top of the escalator he's reaching in 118 seconds. However, in a moving escalator, it takes 40 seconds to reach the top. Find the speed of the escalator. Now, we typically solve it linearly. How do we solve? First, you calculate the number of steps. Why? You know his speed, right? 2 steps per second. In 4 seconds, he takes 2 steps. You know the total number of time he's going for, then calculate the number of steps. Then you calculate the new speed using the second piece of information. You know the total number of steps. You know the new time that is taking 40 seconds. You calculate the new speed. And from that, you calculate the speed of the escalator, right? That's one way of, doing it, right? But if we use ratios, why does it become interesting, right? You know the first time and the second time, right? So on a time speed distance question, my first instinct is to check whether I can use ratios because, it's always the most efficient method. When can I use ratios? There's a before-after situation or scenario 1, scenario 2 situation. Both speeds are given or both times are given, one of the two. I know that I can use the ratios. So here, what are they saying? Time has become 1/3. So, sorry, that's a typo. So, time has become 1/3. From 118, it has become 40, right? 118 to 40. When you want to know that this ratio, always look at using ratios new by old. New is 40, old is 118. So 40 by 118 is how much? If 118 roughly you approximately to 120, 40 by 120 is 1/3. So time has become approximately 1/3 means speed has to become 3 times. Time is 1/3, speed is 3 times. What is the speed of B? 2 steps in 4 seconds because 1, 2, 3 back, right? So every 4 seconds, 2 steps. So B is taking half a step per second. When the escalator is stationary. When the escalator is moving, he is reaching the top in how much? 40 seconds. So we know that the speed along with the escalator, total speed has become 3 times. So half has become how much? 1.5 times, right? 1.5, half into 3 is 1.5. Is B speed changing? No. B speed is still the same, 0.5. So total speed has become 1.5. B speed is still the same, 0.5. What is the speed of the escalator? 1 step per second. Yeah. What step did we bypass here in this particular situation? We bypassed the step of calculating D, the distance, right? We didn't calculate the total number of steps only here because I used ratios, right? So if you can eliminate one whole part and straight away do 1/3, time becomes 1/3, speed becomes 3 times, original speed is 0.5, final speed is 1.5. Here are some, you see that, sir, but you approximated 118 to 120. Why is it? Think about it. I'm giving you a clue. Think about it for yourself. That between 118 and 120, even if I approximate, there is no difference in the answer. The answer is 1. Think about it as to why. Right. So the answer to this question, 1 step per second. Third principle. Reduce the scale of the problem. This is also one way to make things happen. So for example, great chasers in cricket, they always reduce the targets to boundaries, right? Because if you're looking in terms of balls and runs, what will you see? 72 balls, 88 runs, right? 72 balls, 88 runs, it will seem like two numbers which are fairly equal, or the runs are always greater. But if I change it to 72 balls and 22 boundaries, what does that mean? I have so many balls, I only need to hit 22 boundaries, right? Then what do they look at immediately? how many balls from which bowler, how many overs are there, right? And then they know whom can I hit boundaries of and whom can I not, right? This is how batsmen make these things, this thing manageable in their head. If you look at it purely in terms of runs and boundaries also, now even when it is scary, 100 balls, 150, say, suppose I say 80 balls, 120 runs, seems scary. But if I look at it as 80 balls, 30 boundaries, that means 50 balls, even if I leave, it is fine. I just need 30 boundaries, right? And then who can you hit off and whom can you not? You're not waiting till the end. You know that Bumrah is going to bowl at the end. So that means next over, when this person is going to bowl, I have to go attack, right? Similarly, you reduce the scale of the problem. Problem is giving you a very large scale. Reduce the scale and then say, now in this scenario, let me execute the solution and then see if I can find a pattern. When I reduce the scale and I try it out, then find a pattern. That pattern, I just need to repeat for the larger scale. Again, I'm giving you the clue. So take a look at the question. See what I mean by this. Pause the video, see what I mean by this. Sometimes, say, even if it is required for you to, even if you spend a lot of time, 30 minutes also, pausing this video and check and trying it out, it's worth it. This is something that was very useful for me when I was learning how to do elegant solutions, because it would not naturally come to me, right? But when I used to sit and think for a long time and I finally got it, it was very, very valuable because I finally understood something for myself. And then without any other help, so slowly things became easy and I developed confidence in my own this thing. So for me, a good part of, say, teaching now or learning is that spending time on getting better and spending time on these alternate solutions. So I'll show you the question, pause the video and spend a lot of time if required also, but think through. Let 9999 be an integer consisting of a string of 2000 nines and no other digits, 2009 nines. Find the sum of the digits of n square. 2009 nines. And then they're saying you should square it. And then you should ask me to find the sum. So straight away you should know that they cannot be serious, right? They cannot be serious, and there cannot. Second, you might think, oh, but maybe for this sort of this thing, there is some formula, or maybe there is some rule. Why will they give a question if it's such a simple formula for you to put into numbers? So straight away when you see like this, your first thing to look at is, can I reduce the scale? What is the scale here that we know? 2009 nines is the scale. Now I'm telling you, reduce the scale. Instead of 2009s, start with 19. Reduce the scale and execute the solution. What are they asking you? Sum of the square, 2009 nines, square it and sum of the digits of n square. Suppose there is 9. 9 square is how much? 81. Sum of the digits is how much? 8 plus 1, 9. So this, if there is one digit, n is equal to 1, there is only one 9, then it's 9. Second case, 99 square. Now 99 square, you can use the calculator, but if I were you, how would I calculate that? 99 square is nothing but 100 minus 1 whole square. That is a square minus 2ab plus b square. 100 square is what? How much is it? 10,000. Minus 2ab is what? 2 into 100 into 1, 200. 10,000 minus 200 is 9,800. Plus b square plus 1 square is what? 1. So it becomes 9801. So 99 square is 9801. What is the sum of digits? 9 plus 8 plus 1 is 18. So if there are two nines, it is, sorry, that's a typo, that's 99 square. If there are two nines and sum of digits is what? 18 or 9 into 2. So 1 9, it's 9 into 1. 2 nines, 9 into 2. 2009 nines, that is 2009 into 9. Right? 2009 into 9 should always end in what? 2009 into 9 should always end in a 1 because 9 nines are 81. How many options are there with ending in 1? Only one option, option 2. Right? So the right answer on this one, option 2, 18081. Right? So reducing the scale and executing the solution, you didn't even calculate the answer of 18081 because you know the answer is to end in 1. Right? So that's the answer to this question, option 2. If the product of n positive real numbers is unity, then their sum is necessarily what? And they're given you 4 options. Like we did the previous problem, I want to pause this video, reduce the scale, execute the pattern, execute the solution, and find the pattern. Right. Let's look at this. N positive real numbers, the product is 1. That means there are n numbers. How much is n? I don't know. Whatever number of numbers, when you multiply them, the product is 1. Right? So their sum is necessarily what? Can I multiply n numbers? No, absolutely not possible. But can I start with 2 numbers? N numbers, no, only 2 numbers whose product is unity, product is 1. Can we take 2 numbers whose product is 1? Let's take 2 numbers whose product is 1. What is the easiest way to take? 2, and it's reciprocal, 1 by 2, right? It's real numbers, right? So 2 into 1 by 2 is equal to 1. Now let's see, 2 into 1 by 2 is equal to 1. Then their sum is how much? 2 plus 1 by 2 is how much? 2.5. 2.5 is necessarily option 1, a multiple of n. N is 2 numbers. Is 2.5 a multiple of 2? No, this is a decimal number and that's an integer, so it's not a multiple of 2. So option 1, that straight away goes. Is it equal to n plus 1 by n? N is equal to 2, sum is 2.5 of 2 and 1 by 2, equal to n plus 1 by 10. 2 plus 1 by 2 is again 2.5. So option 2, I cannot reject, I cannot eliminate, I have to keep. Never less than n. N is equal to 2, the sum is 2.5. N is, 2.5 is greater than 2, so 3 also I'll keep. Option 4, a positive integer. Sum is 2.5, is 2.5 a positive integer? No. So this goes. Now I'm left with 2 options. Can I try out another set of numbers? Same 2 numbers, n is equal to 2. I'm taking 2 numbers whose product is unity. 2 and 1 by 2 I've tried. Next thing I can try is what? 3 and 1 by 3. If I take 3 and 1 by 3, what is the sum? 3 plus 1 by 3 is 3.33. Now look at option 2. The sum is equal to n plus 1 by 10. N is what? Number of numbers. How many numbers I have taken? 2 numbers, 3 and 1 by 3. Right? So the sum is 3.33. According to option 2, the sum will be what? 2 plus 1 by 2, again 2.5. So is the sum equal to 2.5? No. So option 2 can also go. And your answer on this one is option 3, never less than n. Next principle for this one, the elegant solution. Find the real problem under the padding. Finding the real problem under the padding is that in most of these questions, they'll put a lot of extra information, right? And it's very important to focus on the core. For example, sometime you guys would have known how, if again, I give a lot of cricket examples because that's the easiest thing to understand. In India, at least, a lot of people follow the sport. But you see, sometimes there is a young batsman who's playing, say, a legendary bowler, and they're playing without any fear. What are they actually doing? They're only playing the ball and not the bowler. They're not playing the reputation of the bowler, right? So great batters try to focus on the ball and not the bowlers on the reputation. Similarly, cat problems have a lot of external fluff. What is important? To get to the core of the problem. If I remove all of this, finally I'm not facing a Wasim Akram, I'm only facing a ball, and if this ball needs to be hit, if it deserves to be hit, it will be hit, right? So what is important is to get to the core of the problem. Sometimes you might have to rephrase the problem as well, ask the question in different ways, right? So finding the real problem under the padding. So the next 3 questions are based on the toughest questions or maybe topics that people find very, very tough. Right? So permutations, combinations, and probability. But I'm saying that forget all the traditional methods and think about the real problem and your job will be easy. Let's take the next question. Take a look at this question. Don't try the traditional method. Pause the video and think if there is anything elegant here. You have to arrange 6 books and 6 different subjects in such a row that math book is always to the left of the history book, right? So the standard way of doing is that math book is always to the left of the history book. So you know that can history book be in the first position? No. Why? Because left of that there is no place. So history book cannot be in the first position. History book can be in the second position. First position then to the left is only one place. So math book will be here. And then rest can be arranged in so many ways. Then you'll keep moving this history book. Then you'll keep moving the position of the maths book, and it will be a long solution, right? But think of this slightly differently. Right? If we think of this slightly differently, 6 books can be arranged in how many ways? 6 books, right? 6 books, different books, 6 factorial ways. Now in all of these 6 factorial ways, however you arrange them with respect to math and history, math will either be to the left or to the right of history. No? Immediately to the left, immediately right, doesn't matter. But if you arrange all of these books in all permutations combination, which is 600, all possible ways, 6 factorial ways, maths book will either be to the left somewhere or to the right somewhere. Half the time it will be to the left, half the time it will be to the right. No? Is it that more times it will be left and more times right? No. Whatever ways I arrange, then it will either be half that side and half this side. So if total number of ways is 6 factorial, half the times the math book will be to the left of the history book. So even if they ask you the reverse question, how many ways it's that the history book is left to the maths question, to the left of the maths book, same thing, right? Total number is 6 factorial. Half of the time the math book will be to the left of the history book. So 6 factorial total cases. 6 factorial by 2 is what? 6 factorial is nothing but 6 into 5 factorial. So 6 into 5 factorial by 2, 2 goes 3 times. So it becomes 5 factorial into 3. So the answer on this one, option 4. On this question, I'm telling you that beforehand, it is a photocopy of the previous question. Same thing as it is, or rather the same approach. Use the same approach and solve this question. I'm giving you a big clue that you have to use the same approach. So pause the video, use the same approach and solve, and see if you can get the answer. How did we solve the previous question? We solved the previous question by saying it, with respect to each other, math and history are either to the right or to the left. There are only 2 possible ways that they can be oriented towards each other. Half this side, half that side. Similarly, same approach, A, I and A, these 3 letters, in how many ways can they be arranged with respect to each other? Does not matter, just like in math and history, whatever books are coming between them, side of them, this side, that side, doesn't matter. These 2 are either always to the left or right of each other, only 2 options. Similarly, no matter where all the other letters are, between them, to the left of them, to the right of them, A, I and A with respect to each other can only be arranged in all of these cases in 3 ways. What is that? AAI, AIA or IA. There is no other way. With respect to each other, they can only occupy these 3 positions irrespective of whatever else is between them, whatever other words are between them, right? So in 1 out of 3 cases, the letter I is always in the middle. So no matter how many arrangements, how many ways you arrange all the letters, 1/3 of the cases, in maths and history, what did we look at? Half the time this, half the time this. Here it will be what? With respect to each other in 3 ways, 1/3 AAI, 1/3 AIA and 1/3 IA. So what is the total number of ways of arranging the letters of the word Ravina? Ravina, 6 letters, 6 factorial, divided by 2 factorial. Why? A is repeating twice, right? So why do we do this division? Because A is repeating twice. Because AA or AA, because the 2 same letters, left, right, right, left, it's the same. You won't get a new combination. So 6 factorial by 2, 360. So total number of ways is 360. Only 3 ways in which these 3 can be arranged with respect to each other. How many cases will I be in the middle? 1/3 of these cases. So 360 by 3 is how much? 120. So what's the answer on this one? The right answer on this one is option 2. The next question. In a building with 8 floors excluding the ground floor, Mr. X along with 4 other people enters the lift on the ground floor. 8 floors, 5 people, they enter the lift on the ground floor. Given that each person gets off the lift on a different floor, what is the probability that Mr. X gets off the lift exactly before 3 people? So the moment you're saying that X is getting off exactly before 3 people. There are 8 floors excluding the ground floor. That means ground floor is G, and then you have 1, 2, 3, 4, 5, 6 that you have to press. So now you're thinking he's getting off exactly before 3 people, right? 5 people are there before 3 people means before him 2 people should get down. So then you start doing this maths. First floor he cannot get down, second floor he cannot get down, from the third floor he can start getting down, and then you're doing all of that. But think of this slightly differently. Let's look at it in a different format, right? What is the question really asking you? Just look at the question. What is the probability that Mr. X gets off exactly before 3 people? Exactly before 3 people means he is the second person to get off. So there is a lift. Irrespective of which floor, he should be the second person to get off. There are 5 people and it's asking you the probability. What is the probability that X is the second person to get off? Probability, what's the definition? Total number of ways in which the favorable occurrence can happen divided by total number of occurrences. What is total number of cases? Who can be the second person getting out? Any one of these 5 people can be the second person getting out. That is what? 5. That's the denominator. What is the favorable occurrence? It should be X. So out of 5 people, X should be the person. How many ways can that happen? 1. So what is the probability that out of 5 people, X is the person who's getting off second? Any one of the 5 people can get off second. So the answer is what? 1 by 5. Option 2, right? If you looked at it, we've made it very, very simple. Question says, what is the probability that Mr. X gets off the lift between exactly 3 people? We've changed it to, what is the probability that X is the second person to get off? Any one of the 5 people can be the second person to get off, 1 by 5. Now you might be thinking, sir, is there something fishy here, right? Kuch gadbad hai, kuch golmal hai. Matlab, why did this happen? How did this happen, right? Now, if you want to know how this happened, let's look at the long solution also as to how did this happen. What is probability? Number of ways in which the favorable occurrence can happen divided by total number of occurrences, right? Number of ways in which the favorable occurrence can happen divided by total number of occurrences. Total number of occurrences, what did we remove? When we did the problem using the elegant solution, what did we remove? We took the floors out of the equation, right? We just looked at who's the second person. Now if I have to take that, in this situation, total number of ways I have to calculate. 8 floors, 5 people, everybody getting off on a different floor. Some 5 floors you have to choose out of 8 floors. How many ways can you choose 5 floors out of 8 floors? 8C5, right? You can choose some combination of 5 floors. 1, 2, 3, 4, 5, 1, 3, 4, 5, 6, 1, 4, 5, 6, 7, any combination. So you can choose 5 floors. Now that you have 5 floors, these 5 people within this every combination, you can arrange the 5 people in how many ways? 5 factorial ways, right? Every combination of 5 floors, you can arrange, you have 5 floors. These 5 people you can arrange in 5 factorial ways. So total number of possibilities is how much? 8C5 ways of selecting the floors, and for every floor 5 factorial. So every combination 5 factorial. So 8C5 into 5 factorial. What's happening in the favorable occurrence? You still have to choose 5 floors. So you're still 8C5 ways, you're choosing the floors, right? So whatever, so think about it as 5 numbers, 1 to 5 dashes. Under these 5 dashes, you can write any combination of 4 floor numbers. 1, 2, 3, 4, 5, 1, 3, 4, 5, 6, whatever it is. These are the floor numbers. Who are the people you put? Total number of ways, anybody can go anywhere, 5 factorial. In the favorable case, in the second dash, you're fixing whom? X is the second person to get off. You're fixing X. Remaining, how many dashes are there? 4. How many people are there? 4. How many ways can you arrange 4 people in 4 gaps? 4 factorial. So this becomes what? 8C5 into 4 factorial. Probability is favorable conditions divided by total number of possibilities. So 8C5 into 4 factorial divided by 8C5 into 5 factorial. Everything gets cancelled. 4 factorial by 5 factorial is 1 by 5. Right? That's how everything else became irrelevant. We just converted the problem into who is the second person to get off, because it doesn't matter which floor they're getting off at. So our answer to this one, again, just to repeat, is 1 by 5. Elegant solution principle 5. Follow the story. In the previous example, I said, ignore all the fluff and get to the core. Here I'm saying follow the story. Why am I saying follow the story? The simpler the concept. Time, speed, distance, there is only technically one concept. Everything else derives from it. That speed into time is equal to distance. Probability, no, there is only one concept. Number of favorable occurrences, number of ways in which the favorable occurrence can happen divided by total number of occurrences. So whenever the concepts become very, very basic, you see that the problems become very, very creative, right? It's like saying, I've just given a blank canvas, paint whatever you want, right? So the problem setters, whenever the concept is very simple, everybody knows that, speed into time is distance, or distance by speed is equal to time, they can create huge stories. Now what happens with test takers? The test setter is taking a simple story and weaving it into a simple concept and weaving it into a large story. What is the test setter doing? Test setter is trying to take this complex story and say, how can I convert this story into a formula? Two people are facing, there is a man and there is a policeman, his dog, and a thief. The thief is escaping out of the police station. The dog is running after the thief, and the policeman is running after the dog in that sequence. Then every time the dog, obviously dog is faster than the both of them. The dog is, reaching the thief, it's running back to the cop. And this whole thing is happening, and they're asking you, how much distance does the dog cover? You're thinking, oh my God, the dog is going back and forth. And you're trying to think, how can I do? Is there a formula? Is there a formula? Is there a formula? Right? So it becomes very, very scary. So every time there is a story, don't try to fit the story into a formula. Try to just follow the story. Don't try to write equations. The longer the problem, the more this thing. Do not try to write equations. You realize when you see a long story problem that if you say let the distance be d, you're done. When what do you do? Sir, you're saying don't write the formula. What should I do? Visualize the situation, right? Visualize the situation as to what will happen, and then what you need to do. Visualize the situation. There is only one concept, speed into time is equal to distance, right? Visualize the situation and then only use the logic. Most of the time when we read these story problems, and you will encounter them, we don't visualize the situation. 2, we don't follow the story, we try to fit the story into a formula. If you do all of these, you will easily get this. So in the next few problems, I'm telling you beforehand, don't be tempted to write an equation. Don't be tempted to use a formula. Follow the story and see what's happening, right? Let's look at the first question in this sequence. Pause the video, read this question, and do not try to form an equation. Even if you take a very, very long time, you will be very happy if you get the answer yourself. And even if you make a slight mistake, but you got the approach right, you'll be very happy. Pause the video and think about an elegant solution. It says 2 towns A and B are 180 kilometers apart. Okay. Car 1 and car 2 start traveling from A to B respectively towards each other. Okay. Their speeds are in the ratio 1:2. Straight away, we'll write X and 2X. And they start at 7 a.m., 8 a.m. respectively. So car A is starting at 7 o'clock. Car B is starting at, car 2 is starting at 8 o'clock. After they meet at C, they return to their starting positions and again start traveling towards each other. In order to meet car 1 for the second time at C, car 2 halts at C. For how much time does it halt? Right. If you try to write an equation for this, worst possible idea. But how can you do this? Visualize the situation. Car 1, 7 o'clock, car A at point A. It is starting. Car 2 is starting at 8 o'clock and from position B. This starts, and they're meeting at C. Now, first time to cover this distance and reach this spot, car 1 is starting how many hours earlier? It's starting 1 hour earlier. So I've started 1 hour earlier and I've reached a point. To reach the same point, car C started 1 hour later from their point, right? Now, irrespective of everything else, so car A needed 1 hour more to cover the distance that it covered. Now, after meeting, they're immediately going back and coming in. So the same distance, right? They're going twice. So if I look at this problem, to travel one way, A starts 1 hour earlier. Here they're going back and again coming back. So to travel two ways, to travel the same path twice, back and forth, how many hours more will A take? A will take, or car 1 will take 2 hours more, right? So I wrote A, it's actually car 1 will take 2 hours more, right? Because it's the same thing. To cover that distance from wherever A is here, B is here, to cover that distance, I took 1 hour more because I started 1 hour earlier. Now when I'm starting at the same time back, I will take how much? 2 hours more, right? So how much time will C wait for, B wait for after going there? Car 2 will go there and wait for 2 hours, right? Now I can change this, into another thing. For example, you and your friend decide to play cricket, your children, and both of you decided that, okay, you need to get a few things, he needs to get a few things. By the time you reach, he realizes that he's forgot to get the pads, and you realize that you forgot to get the gloves, right? Now you've reached there. His house is 1 hour farther than your house. But without gloves and without pad, you cannot play because you're playing with a cricket ball, right? With a proper cricket ball. So what happens? You and your friend have to go back. He has to go back to his house and get the pads. You have to go back to your house to get the gloves. Both of you have reached this thing at 4 o'clock. If you go immediately to your house, get the gloves and come back, what will happen? You will have to wait for your friend. Why? Your friend's house is 1 hour farther than your house. Right. So what will you do if you're smart? You know that one way you will spend, he'll take 1 hour more. Coming back, he'll take another hour more. So what will you do? You'll go home, watch TV for 2 hours and then start, right? Because otherwise you have to come there and wait for 2 hours. So beautiful problem, B will have to wait for 2 hours. If you try to use an equation here, some of you this would have struck your mind, right? But you would have made a simple mistake. That he takes 1 hour more, so now also B has to wait for 1 hour. That 1 hour is fine. If you made that mistake, as long as you didn't write the equation and you thought 1 hour, it's fine. Now that you know it's twice and 2 hours, it's good. So the answer to this one, waiting for 2 hours. Next question. Again, pause the video. You will be able to write an equation and solve this problem for sure. I have absolutely no doubt. There's an equation. That's a very, very simple method. But is there a non-equation method, right? Again, this friend of mine who is a multiple time 100 percentiler. So he's like, I was like, why do you do these methods? He's like, I hate equations and I hate my handwriting. So, I go together, this way. Right? So pause the video, think about a non-equation method. You'll anyway get it to the equation method. If I need to write this equation, what will I know? What do I know? A, B, and C play a card game once every day for 30 days. 30 days play cards. Sole loser of every game gives the other two 1 rupee each. If A loses, I'll give B 1 rupee, I'll give C 1 rupee. They keep a record of their wins and losses. At the end of the day, what is the net story? That they owe B 6 rupees. In how many games was B not the loser? Or rather, in how many games did B win? So if I have to write the equation, fairly simple. I take what is being asked as X. Suppose B was not the loser in X games. X. He was not the loser. Somebody else lost. That means how much is he getting for this? You get 1 rupee. Whoever loses gives the other two guys 1 rupee each, right? So B gets 1 rupee. So X number of games if he was winning, which is what they're asking for, X into 1, minus if he lost, how much does he have to give out if he loses? 1 rupee each to the other two. That means 2 rupees. So minus 2 into 30 games in total minus X. is equal to $6 is how much he got at the end. So x minus 2 into 30 minus x is equal to 6. So what do I get? X minus 60 plus 2x is equal to 6. That means x plus 2x, 3x minus 60 is equal to 6. 3x is equal to 60 goes that side, 66, x is equal to 22. You'll get the answer. Right? Absolutely no doubt about that. But is there a better way if you follow the story? What if B does not lose a single game? Let's start from that. B does not lose a single game. Somebody else loses. How much does he get for every game he does not lose? He gets 1. Right? That means for 30 games, he gets 30 rupees. Now suppose one of these victories becomes a loss. What happens? It says that, Acha, we found that, okay, no, actually in the last game, C was the winner. What happens? B got 1 rupee for it, 30 bucks. He has to first give that 1 rupee back to C, right? Then what does he do? Because that he got from whoever the guy was. It was this earlier. It was found out that C had lost, so C gave 1 rupee to B, and B gave C gave 1 rupee to A also. B did not lose a single game, so 1 rupee he got 30 bucks. But now it's found that C himself is the one. C is the one who won that game. What do? You'll give that 1 rupee to C, and then because you are the loser, because B lost that game, you have to give 1 rupee to the other two, right? So instead of 30 rupees, you give the 1 rupee back and you have to give 2 rupees to the other two. Instead of 30 rupees, you get 27 rupees. So every victory, when it becomes a loss, from 30, it became 27, means every victory into a loss means minus 3. Now, instead of 30, what has happened? Right? Instead of 30 rupees, if he didn't lose a single game, he could have gotten 30. Instead of 30, he got 6. That means how much did he lose? 24 rupees. One victory becoming a loss is 3 rupees. 24 rupees loss means 8 games were lost. So out of 30, 8 games were lost. How many did he win? 22. Right? If B earns 6, then his earnings had fallen by 24, which means he lost 8 games. Total number of games is 30. He lost 8 games, means 22 games, he was not the loser. You might say, sir, that equation was easy. Yes, equation would have been easy, but it's always good to know these things, that there are these possibilities that exist. So the answer in this one is B won 22 games. The next question. Again, this is related to follow the story. A stick of 7p length is cut into 3 parts and they form an isosceles triangle. What is the range of x if it is the length of the equal side, right? So stick broken into 3 parts and it's an isosceles triangle. That means 2 sticks are equal of length and 1 thing of unequal length. And if each of these equal things is x and x, what is the range, right? So try this question out, pause the video. Right. Now you might think, sir, it's a geometry question. How do I do this? Follow the story. Think about it. They're asking you for the range of x, right? Now, there are 2 scenarios, right? They're asking you for range. That means each of these equal sides, x and x, what is the maximum value it can take and what is the minimum value it can take? Now, suppose in this isosceles triangle, we are saying scenario 1 is the 2 equal sides are as large as possible. If these 2 long sides are as large as possible, what will become the smallest? The third side becomes as small as possible. Can the third side become 0? No, it cannot become 0 because it won't be a triangle then, right? That means some small value out of 7p you have to give. All the rest you'll give to these 2 sides, the equal sides. So some small value, so these 2 sides together will be slightly less than 7p. Small value you'll give there, right? 2 sides together are slightly less than 7p maximum. So 7p is slightly less than that. That means they're saying x and x, right? Equal side is x. So one side will be how much? Slightly less than, maximum value will be slightly less than the total length, slightly less than 7p by 2, right? Can the third side be 0? No. It has to have the smallest possible value out of 7p. Rest has to be given to the 2 equal sides. If the 2 equal sides at the maximum together will be slightly smaller than the total. So 2x is slightly less than 7p, x is less than slightly 7p by 2. At the maximum end, it is slightly less than 7p by 2, right? So you have this. Now what's the next scenario? They're asking you for the range. You've calculated the maximum what it can be. Range means next is minimum. Now, if these two sides, previously we made them maximum, so the third side was as small as possible. Now, what if at the other end, these two sides are small and the third side is getting as large as possible? Third side is getting as large as possible compared to the as two sides. So immediately as soon as I say this, something should strike you, no? In a geometry situation, two sides, the third side is getting large, right? What is the rule? Sum of two sides should always be greater than the third side. Right? Now this is a geometry. One of the reasons I love geometry is that most people hate geometry, that some people like, some people hate. So is that it's a very visual thing. Sum of two sides is greater than the third side. I'll explain why should it be so. I can easily explain it. Explain it without geometry only. Take two sticks of equal size two sticks. Take this top stick, break it into two parts. Make it into two parts, maybe without breaking the stick completely so that you can move it up and down. Now, can you place this top stick in such a way, right, that the two sides need to touch the edge? If the two sides are equal, if the two sticks are of equal length, you can never place it exactly at the edge. Once you bend it, it will always be inside the edge, right? Only when the top stick is larger can you take it up and make it touch the edge. Because if it is the same size and you break the top thing, it can never meet the edge, it will be inside the edge, right? So, but what is a triangle? Triangle is a closed three-sided figure. If it is inside the two endpoints, it will be an open three-sided figure, which is why the top stick always has to be larger than the bottom stick. This is why if you break it, that is nothing but sum of two sides has to be greater than the third side. So you know that I want to make the third side as large as possible and these two as small, but still the sum of the two sides has to be greater than the third side. So this means what? These two equal sides should always be greater than the third side. 7p. Sum of two sides should be greater than the third side. Sum of two sides, 7p, if it's equal to the third side, how much will each be? Total is 7p. Both are equal. So this will be 7p by 2 and this will be 7p by 2. Two sides together 7p by 2. One side, the third side is 7p by 2. They're equal. But can they be equal? No. Sum of two sides should be greater than. So these two sides together, bare minimum, they should be slightly greater than the third side. So 2x together slightly greater than half. So slightly greater than 7p by 2, because it's equal means 7p by 2, 7p by 2. It should be slightly more than that. 2x slightly greater than 7p by 2, x slightly greater than 7p by 4. Yeah. So one side will be slightly greater than 7p by 4. So the range, the minimum is slightly greater than 7p by 4. The maximum is slightly less than 7p by 2. What is the option here? Option 2. The next question, the last principle. Always have the answer options in mind. You need to always have the answer options in mind. A great cricket player is always scanning the field to know where the gaps are. They always know where the gap is and how that's happening. So great batters are always scanning the field. Similarly, because they're trying to actively exploit the gaps. So because CAT is like a T20 game only, you have to always have the options at one point just to see, can I exploit the gap or not? For example, suppose you know that there is a gap left behind. So third man, there is nobody there. You know that. Doesn't mean that every ball you try to play that. If it's a pitched up ball, maybe you'll go straight down the ground, right? But you need to know that because there is a gap there, right? I'll always look at it. You should know that the gap is there. If it is convenient, the ball is falling exactly in that format, you will exploit the gap, right? So let's take this. We are going back to which question now? We are going back to the second question, right? And in this second question, there is an easy way if you look to solving, if you want to look at the answer options. So there is an easy way to solve it if you're looking at the answer options, but only after. It doesn't start at the beginning. You're not substituting the answer options. The best part is, I had discussed the other method in class, and then I had taken that class for quite a few times. And then a student comes to me and says, in one of the classes, sir, I used another shortcut. I used ratios. I said, sir, I used another shortcut. till the middle I calculated. After that, I used a shortcut. I was like, great, tell me what the shortcut is. What did the student do? B takes 2 steps in 4 seconds. 1, 2, 3, back. So B's speed is half a step per second. Totally, he reaches the top of the escalator in 118 seconds, right? 118 seconds. So what did he calculate? 118 seconds is the time. Speed is half a step per second. Distance covered is what? 118 into 1 by 2, 59. Now, this is actually incorrect. The student made a mistake here because the total answer is 60. Because the speed of half a step per second is not uniform. The person is traveling what? 1, 2, 3, back. 1, 2, 3, back. So every set of 4 seconds, they're covering 4 steps. In 118 seconds, how many sets of 4 are there? 118 by 4 is how much? 2, remainder 3, 39 sets of 4 are there. Sorry, there's remainder, yeah. 118 is 4 goes twice, remainder is 3, 38, 9 times. So 29 sets of 4 are there, and there is a remainder of 2 seconds. In these days, 29 sets of 4 seconds, every 4 seconds I'm taking 2 steps. 29 into 2 is how much? 58. 2 seconds are remaining. Fresh start after 4 sets. 2 seconds, how many steps will I take? Already I've taken 58 steps. 59, 60. What happens in the 119th second? 61. What happens in the 120th second? Back to 60. So 119 seconds or 118 seconds or 120 seconds, I'm taking the same number of steps because after 116, which is 58, 59, 60, 61, back to 60. Which is why when I did that shortcut of 1/3, it did not matter because by approximating to 120, because both in 118 seconds and 120 seconds, I'm taking the same number of steps. Anyway, the student made this mistake. 118 into 1/2 is 59 steps, but it did not matter. Why? The moment he calculated 59 steps, he straight away looked at the answer options. He looked at the field placing. Pause the video, look at the field placing, and tell me if you can come up with the answer. Look at the options. What do you know? However, on a moving escalator, he takes 40 seconds to reach the top. Find the speed of the escalator. Suppose speed of the escalator is 1 step per second. In 40 seconds, how many steps will the escalator take? 40 into 1, 40 steps. Right? Now, take a look at the next one. Right? 2 steps per second. 2 steps per second, the escalator is traveling at for 40 seconds. How many steps will it cover? 2 into 40 is how much? 80. So total number of steps itself is how much? We know that when escalator was stationary, when B went from bottom to top, total steps is 60. The student incorrectly calculated 59. But total steps is only 60. At 2 steps per second, escalator alone will be covering how many? 80 steps. Right? So no answer apart from option 1 is even possible. That's why the answer is option 1, 1 step per second. Finally, just to sum up about the elegant solution, we know that there are different principles. So the first thing is looking out for magic numbers. Right? Are the numbers slightly special? Knowing the standard alternatives, I discussed only one standard alternative in this, which is the time, speed, distance and ratios. But plugging answers, taking n is equal to 1, all of those are standard alternatives in different situations. Right? Principle 3, reducing the scale of the problem and executing and then finding a pattern. Finding the real problem under the padding, reducing and rephrasing the problem. Large story problems, typically in arithmetic, where you follow the story. Most importantly, always have the answer options in mind because they are like the fielders. And actually, there is one thing that is most important, which I didn't mention as a principle so far. Never forget you're playing a T20 game. That is very, very important because this is actually an aptitude test. Unless this mindset is there, maximize, 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 faster, 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 you're not going to this thing. Because students a lot of times say, sir, आप करते हो, पर आपको चमकता है. आपको चमकता है, sir, इसीलिए होता है. It's not because चमकता है. Unless you look for something, you don't find it. So you should look for it. Only then will you find it. The only thing जो चमकता है that strikes you, right? Without you finding it is what? Lightning. So apart from that, you have to look for something. Because Dhoni is looking for a second when he's running. He runs the first one fast, puts pressure on the fielder and gets the second, right? So don't look at all of these as these stunts are performed by professionals, don't try it at home. No. You also are trying to become a professional by taking the CAT, cracking it and getting into an IIM or a great school, right? So don't think of it as a separate thing. Think of it as these stunts you also have to learn to do, because they are moving to play a T20 match from what was a erstwhile test match that you were playing in school. But as they say these days, even test matches, people are playing like baseball. People are using baseball and playing like a T20 match, right? So hope you enjoyed this video called The Elegant Solution. Thank you.